Welcome back. In this video, we'll be finishing up section 7.1, which is about confidence intervals. Last time we did the first half of section 7.1, where we talked about just what is a confidence interval. We talked about the difference between a point estimate and a confidence interval. We talked a little bit about margin of error, which is given right here for proportions specifically. So in this section, we do a little bit more involving margin of error. We'll do a few more examples of finding confidence intervals, and then we'll look at how to find sample size. So that's what we're working on here. So this definition is repeated from before, just for your reference. You already have it in your notes. It says when data are used from a simple random sample are used to estimate a P, a population proportion, the margin of error, which is capital E, is the maximum likely difference between the observed sample proportion, P hat, and the true P. It's also called the maximum error of the estimate. And basically that's the number that we ended up adding and subtracting to the P hat to give us the left and right ends of our confidence interval. So that formula is repeated here. It was Z alpha over 2 times square root P hat Q hat over N, where N was the sample size. There were a couple of commonly occurring confidence levels, 90, 95, and 99. And so working through those, if we're looking for a 90% confidence interval, then that means, well, all the data is 100%. If 90% is in the middle, that means that the rest of it is 10%, and that will be our alpha. So the confidence level is 1 minus alpha. So if there's 10% in the two tails, then each tail has 0.05 in it. So we'll be finding Z 0.05. If the right tail has 0.05 in it, then 0.95 is to the left of our Z alpha over 2. And looking that up in the Z table, we get 1.645. So we had gone through this before. We saw for these commonly occurring confidence levels, 90, 95, and 99, that the corresponding Z's are 1.645, 1.96, and 2.575. So you may want to write those down like separately, just so that you can grab those pretty easily without having to go to your table or rederive them every time. All right, so let's go ahead and try this. So it says use the given sample data and confidence level. Part A, what does part A say? It says find the best point estimate of the population proportion P. So the best point estimate is just the sample proportion. So let's see. It says from a KRC research poll in which respondents were asked if they felt vulnerable to identity theft, the N was 1,002. So there were 1,002 total respondents. 531 said yes. So it's 531 out of 1,002. So that will be our P hat. Just for our reference, as a decimal, that is about 0.5299. Okay. B, it says identify the value of the margin of error E. Okay, so for B, we're asked to make a 95% confidence interval. So 95% confidence. That means that we'll have 95% of the data in the center of our distribution. So that means 5% is the rest of it, or 2.5% is in either tail. That will give us a Z of 0.025, which was 1.96. The formula for margin of error was Z alpha over 2 times that square root of P hat Q hat over N. We just have to put in the information that we have in this particular example. So the Z alpha over 2, we saw right now was 1.96. We'll multiply that by this square root. P hat, 531 over 1,002, and that worked out to be 0.5299. And then we'll subtract that from 1, to get the Q hat, and that's 0.4701. And then our sample size was 1002. So let's go ahead and calculate that. All right, so I'm getting 0.0309. Okay, and so our P, our confidence interval, is P hat plus or minus E. So our P hat was 0.5299 plus and minus the E we just calculated, 0.0309. Writing it as an inequality, we'll take 0.5299 minus the 0.0309, get 0.499. And then 0.5299 plus 0.0309, and that will be 0.5608. We'll call that 0.561. We'll just do it to 3 decimal places. All right, so there's our confidence interval. That was part C. We did that. That's actually right there. And then D, write a statement that correctly interprets the confidence interval. So we could say we're 95% confident that the interval 0.499 to 0.561, there I've written it a third way, contains P. Okay. All right, so we've answered all the parts of that. All right, so another example. So here, this one says, in a survey of 1,001 US adults, 501 believe the role of unions in protecting workers' rights is as important today as in years past. So first of all, we're going to get point estimates for P and Q. So P hat will be 501 out of 1,001. And so we'll need an approximation for that, 0.5005. And Q hat is 1 minus P hat. And that is 0.4995. Okay. All right, so then next up, we want a 95% confidence interval. So let's get E, which will be our Z alpha over 2, P hat Q hat over N. I think it's a good idea to go ahead and write formulas each time you use them, and then before you know it, you're going to remember the formula. All right, so then for a 95% confidence interval, we saw that our Z 0.025 is 1.96. And then we got this big square root. P hat, Q hat over N. Okay, so let's go ahead and calculate that. Okay, get 0.0309. Okay, and then we'll add and subtract that to our our point estimate, P hat of 0.005, 5.005. That's 0.4696 for the lower end. And then 0.5314 for the upper end. Okay. And then, so our interval ends up being 0.4696 up to 0.5314. All right, so now we're going to, for the same story involving the unions, we basically want to do the exact same thing, only we'll have a 99% confidence interval. So the process is going to be really similar to what we did in B, only instead we'll have, because it's 99% confident, we'll have a Z 0.005 of 2.575. So in our last calculation where we used 1.96, we'll be using 2.575. So our margin of error E will look like 2.575 times that same square root. All that's really changing here is our C. So let's go do that. So while I'm typing this in, you can think about whether the interval is going to end up being wider or narrower than it was before. So we get 0.0406. All right, so then the left end of the interval will still take 0.5005 plus or minus that 0.0406. So we'll have 0.4599. And then we'll have 0.5411. And that will be our 99% confidence interval. And so in comparing that to our last one, we want to think about which is a narrower interval. The 95% confidence interval went from 0.4696 up to 0.5314. If we want to be 99% confident in our estimate of P, you'll notice that the left end is less and the right end is higher. So thinking about it, that makes sense. We have, we're in constructing our estimate, we have P hat, and we're hoping to capture P. And so if we go out a certain ways, the P may or may not be in there. We can have a certain amount of confidence in whether that interval contains P. If you want to be more sure of having the P, think about it. If you want to be more sure, then you widen the interval. Okay? So, and if you wanted to be, if you were okay with being less sure, then you can make the interval narrower. So that was kind of the purpose of this example. Okay, a little more practice just at rewriting an interval. In 10 here, it says we have an interval expressed in inequality notation. We want to write it using the plus minus symbol. And then number 11 is in interval notation, and we're going to rewrite it as a three-part inequality. So here we want to figure out where P hat is to begin with. And so thinking about how confidence intervals work, remember that they're centered at P hat, right? So we need to figure out this interval 0.165 up to 0.335, where the middle of that interval is. And so we'll find the mean. And that will tell us where the middle of the interval is. And that has to be where our P hat is. Okay, now it looks like 0.25. Okay. So then let's subtract 0.335 minus 0.25. Okay, that's 0.085. And 0.25 minus 0.165 is going to be 0.085. And that shouldn't be too surprising either. So what we ended up with was this P hat in the middle. We should have P hat plus E at the right, P hat minus E at the left. Our p hat this time is 0.25. The interval goes up to 0.335 and down to 0.165. And the difference is 0.085 on both. So to answer the question for number 10 here, it's going to be 0.25 plus or minus 0.085. For number 11, it's going to be really similar. So here, our interval is from 0.0268 to 0.133. So our first step is to find the center of that interval. And that's 0.0799. Okay, and then let me find the difference between the ends. So 0.133 minus 0.0799. That's 0.0531. I'll leave it to you to check the other end, but our margin of error is going to be 0.0531. So the left end is our center, 0.0799 minus 0.0531 will be up to P, and then 0.0799 plus 0.0531. All right, so that takes care of both 10 and 11. So basically the purpose of those two was to get a little practice at rewriting confidence intervals in different formats. Okay, so here we're going to produce a confidence interval from a Prince Market research poll in which respondents were asked if they acted to annoy a bad driver. The N is 2,518, the X is 1,083 who said that they honked. We're to find a 90% confidence. We use a 90% confidence level. All right, so let's go ahead and look. All right, so let's see how this plays out. So since it was a 90% confidence interval that we're to produce, that means our part in the tails is 0.10. In two parts, that's 0.05. So we have Z 0.05. That works out to be 1.645. Our X was 1,083 out of 2,518. So that's where we'll calculate our P hat. It's 0.4318. Subtracting from 1, we'll get 0.5602. So then our E was our Z alpha over 2, which is 1.645, times the square root of P hat, that's the 0.4318, times Q hat, which is the 0.5602, divided by N, which is the total number of respondents, which was 2,518. Going through the calculations, we end up with an E of 0.0161. So to finish finding the confidence interval, we'll have P hat plus or minus E. Our P hat was 0.4318 plus or minus that 0.0161. All right, that's 0.4157. Up to 0.4479. All right, so there's our completed 90% confidence interval. Okay, this question has multiple parts. We'll just go through each part in turn. So it says a Consumer Reports Research Center survey of 427 women showed that 29% of them purchased books online. So what's different about this one is we're actually given the percentage already, so we don't need to calculate it. So we're told basically that our P hat is 0.29. Among the 427 women who were surveyed, what is the number of women who said that they purchased books online? So that's just the 29% of the 427 women who were surveyed. And that's It says 183.183. Of course, we're talking about a number of women here, so it only makes sense to round to a whole number. So it looks like 183 women. Now it says find a 95% confidence interval estimate of the percentage of all women who purchase books online. So we need more space, so we'll do that down here at the bottom. We want a 95% confidence interval. We're told that our N is 427 and our P hat is 0.29. All right, so let's get to work on finding our E. Our E is going to be Z alpha over 2 square root P hat Q hat over N. Since we're doing a 95% confidence interval, our Z alpha over 2 is 1.96. Our P hat, remember this time we were given it, it was 0.29. And then 1 minus 0.29 is going to be 0.71. Our sample size was 427. So going through the calculations, 0.043. So then 0.29 plus or minus 0.043 is 0.247. And the upper end, 0.29 plus 0.043 will be 0.333. So then our confidence interval is going to be 0.247 less than P less than 0.333. Okay, so that takes care of the second part. So then for part C, it says, can we safely conclude that less than 50% of all women purchase books online? Why or why not? So we went through this procedure of finding a 95% confidence interval. And so we're 95% confident that our interval between 0.247 and 0.333 contains our P, right? And since we're 95% confident in that, the upper end is 0.333, which is pretty far below 50%. I would say yes. So we could say yes, and then we could say since something like since the upper end of our interval, 0.333, is so far below 50%. Okay, contrast that with part D where it says, can we safely conclude that at least 25% of women purchase books online? Why or why not? So there it's 25%, and our interval goes down to 0.247, which is a little below 25%, and then it goes up to 0.333. So I think I am kind of sure that the true proportion would be at least 25%, but it should be clear that we should be less sure about it in a way, because our interval only goes down to 0.247. So that is closer, right? So compare that with C. I would say not really, since the interval isn't fully above 25%. Okay, and then lastly, part E, what do the results tell us about the percentage of men who purchase books online? And that should be pretty easy. It tells you nothing, right? Our data was about the percentage of women who shop or purchase books online. So it doesn't tell us anything about men. That's a different population. Okay, so that's the end of this example. So let's go on to see what we have next. So the last few examples we've been working on producing confidence intervals, but a kind of step that is going to happen before that is to collect the data. And to do that, we would need to know what the sample size is. And so the inputs to this procedure would be like, how sure do you want to be? Okay, if we want to be 95% confident in the proportion of something, how many people do we need to survey? And so that's what this next part is about. So we'll start with the sample size, right? This we've seen that E, our margin of error, depends on the sample size. So that's the N, right? So E is Z alpha over 2, which is derived from our confidence level. And then that's times the square root of P hat Q hat over N. So if we want the sample size, that's going to be N. So we're just going to use a little algebra to help us solve for N. So let's do that. So we're going to divide both sides by Z alpha over 2. And that will be the square root of P hat Q hat over N. And then square both sides, right? To solve a radical equation, you're going to square both sides. Squared. Okay, we're ultimately after the N. So what we'll want to do next is take reciprocals of both sides. So this will give us Z alpha over 2 over E squared. That will be N over P hat Q hat. And then finally, we're going to multiply both sides by P hat Q hat to get the N all by itself. So N will be Z alpha over 2, so let me write that a little bigger, over E squared times P hat Q hat. So that will be our formula for the sample size. The inputs to it are going to be Z alpha over 2, which comes from how confident we need to be, and then the E, the margin of error, that is going to come from how wide we want the interval to be. Okay. So fine print from the book. P will be our population proportion as always, P hat the sample proportion, and the sample size. E is our desired margin of error, and we have to remember to turn that into a decimal. So for example, if we want it to be within 3%, we should right away use 0.03 for our E. All right, and then our Z alpha over 2 is our critical value as before. Okay, so then our formula, we just saw Z alpha over 2 squared over E squared, and that's times P hat Q hat. So a question that comes up is, well, the P hat and Q hat come from the sample, right? And so if we're determining the size because we're going to do the sample, how do we know what the P hat and Q hat are if you haven't even done the sampling yet? And so the answer to that question is basically, do you have maybe some kind of prior study that you could use as an estimate? If you don't have some kind of an estimate, then you're going to use 0.5 for both. So if you have no, let me put this up here. If you have no P hat, Q hat, use 0.5 for both. Okay, it turns out that that's going to give the most conservative estimate or the most conservative sample size. All right, so then what we'll do next is try it. So I guess that's here, yeah. So formula for the two sample sizes. If you have an estimate P hat, use the top one. If you don't have an estimate for P hat, use the bottom one. All right. A couple of cautions, and then we'll try an example. Okay. First of all, if it's your margin of error is like 3%, remember that needs to be a decimal. So it needs to be 0.03. Don't use 3 for it. Okay. And then also, if you're using, if you need to be like 95% confident, remember to replace that Z alpha over 2 with 1.96. Sometimes people will use 90.95 or 0.05 in its place. All right, so let's try it with this example. Let's say that we want to estimate the percentage of Republicans among registered voters in California. We're going to use 0.03 margin of error and have a confidence level of 90%. We'll assume that P hat and Q hat are unknown. So we want to come up, we're not making a confidence interval this time. We want to figure out how big of a sample size we would need to make a 90% confidence interval and have the margin of error end up being 0.03. And so this will tell us the sample size. So N is going to be Z alpha over 2 squared over E squared times P hat Q hat. So then again here, we're told that the P hat and Q hat, or P hat is unknown. And so instead of having a P hat, Q hat, we're using 0.5 for both. Okay, assume that P hat and Q hat are unknown. All right, so we want a confidence level of 90%. Since it's a confidence of 90%, our Z.05 is 1.645. So we'll have 1.645 squared divided by E squared. And our E, our margin of error, is supposed to be 0.03. That will be squared. Our P hat and our Q hat are unknown. So we're going to use 0.5 for both. That 0.5 times 0.5 is where the 0.25 comes from. So then let's calculate. Okay, so I'm getting 751.7. Since this is a number of people that we're surveying, it needs to be a whole number. And so we'll always round up here. That is going to give us a more conservative answer if we always round up. So this one we would have probably rounded up anyways because it's 0.7, but we would always round up to give a more conservative answer. So 752 would be our sample size. Notice in this, we don't need to know the population. And that's pretty interesting. You don't need to know how many people are in California. All you need to know is the 752. So that there is pretty interesting. You don't actually need to know the population. Okay, one more example and then we're all finished with section 7.1. All right, so the story here, you're the operations manager for American Airlines and you're considering a higher fare level for passengers in aisle seats. People like to sit on the aisle so that they can get out more easily. You want to estimate the percentage of passengers who now prefer aisle seats to see if it's worthwhile. So how many randomly selected air passengers must you survey? Assume that you want to be 95% confident that the sample percent is within 2.5 percentage points of the true population percentage. Okay, so let's try. Part A, assume nothing is known about the percentage of passengers who prefer aisle seats. So we have N, we'll have Z alpha over 2 squared over E squared P hat Q hat. Okay, and then for this one, we want it to be 95% confident. If it's 95% confident, then our Z will be 1.96. Our margin of error was 2.5 percentage points. 2.5% is 0.025. And then here it says, assume nothing is known about the percentage of people who prefer aisle seats. And we'll use 0.5 for both P hat and Q hat. All right, so we get 1537. Okay, so about 1,537 passengers would need to be surveyed. All right, the difference here in part B, it says assume that there was a recent survey that was done that suggested about 38% of passengers prefer an aisle seat. Okay, so if we're going to go off of this prior study, it's going to be similar. The only piece that will change, we still want the same confidence level and the same margin of error. The only piece that is going to change is the fact that now we're going to use 0.38 for our p hat. And so then our q hat will be 0.62, which is 1 minus the 0.38. So let's calculate. Okay, and that's 1,449. I've rounded up there. So that's interesting. You'll notice that the sample size is lower when we had a prior estimate. So we were able to get away with sampling fewer people, basically, based on having this prior estimate for the 38%. All right, so that takes us to the end of section 7.1. Make sure to practice with that, and then let me know if you have any questions, and have a great day.